Hi, everybody. This is the lesson 3 of unit chapter 5 of the book. Lesson 3 on X and Y intercepts and interpreting relations. Okay, so just to review, a relation is a connection between two quantities, and a relation can be represented graphically by a set of ordered ordered pairs. Sorry. Trying to do this in a real rush. Ordered pairs. So like that's an X and a Y values. The first component of a set of ordered pairs is the X coordinate. X always comes first, and that's the input. And the values, the values of the input are the independent variable. And then the second one is the Y coordinate, also known as the output, and that's the dependent variable because it depends on what you put in. Okay. So let's look at X and Y intercepts. This is a super important concept. The X-intercept is where your graph intercepts or crosses the X-axis. So the X-intercept here, I'm going to just highlight that in blue. So this is an X-intercept, this is X. These are all of our X-intercepts. So let's, in blue, the graph 1 crosses the X-intercept at -3, 0. Graph 2 crosses it at -2, 0. It's not a 6, that's a 0. And 3, 0. And graph 3 crosses the x-axis at -4, 0. And 4, 0. And let me just fix this one because that changed my 4 into a 9. The stylus that I use. Okay, what do all these have in common? Well, they all have their y value equals 0. So this causes some confusion for a lot of students because the x-intercept happens when y equals 0 because you haven't moved anywhere in the y direction if you're sitting on the x-axis. Okay, so just, think about what it means when we talk about an x-intercept or a y-intercept, okay? Okay, so then we're going to look at the y-intercept, and I'm going to do that in pink or purple, whatever this one is. So where does it cross the y-axis? This one crosses up here. This one crosses up here. This crosses twice. And then I'll use my purple pen to do this. So graph 1 crosses the y-axis at crosses the y-axis at 0, 5. Graph 2 crosses it at 0, 5. Graph 3 crosses at 0, 4, and 0, -4. So what do these all have in common? These all have x equals 0, okay? So these are the y-intercept. We almost always abbreviate it as y-int, and these are the x-ints. Don't usually say it that way, but we write it that way. Okay, next page. So here's your definition. The x-intercept of a graph is the x-coordinate of the ordered pair where the graph intersects the x-axis. It always happens when the y-coordinate is 0, and you can give it as a value, like just the x value, or the ordered pair, which would be the x value, 0. The y-intercept, same thing, but reverse. So make note of this, that to find, if you've got an equation and you're asked to find the x-intercept, you ask yourself, what is true when we're crossing the x-intercept? So when I'm crossing the x-axis. So when I'm crossing the x-axis, y equals 0, and I'm going to find my x value. If I'm looking for the y-intercept, I need to know when x is 0. So I'm going to set my x to 0 and solve for y. And we will be doing this again and again and again and again. Okay. The equation of a graph can be written in different forms that are equivalent. So there's 3 forms that we're going to look at this year. And we'll look at those later. But for now, where you can find it by using these directions here for any equation. Okay. So let's do this algebraically for for this equation here. So my equation is 3y equals 5x plus 15. And we're asked to find the x-intercept, and that means that y equals 0, okay? Because I'm looking for where it's going to cross my x-axis. So when I cross the x-axis here, let's just draw a line. Where I cross the x-axis here, this is my x-intercept. The y value equals 0. So I'm going to make my y 0, so this becomes 3 times 0 equals 5x plus 15. So 0 equals 5x plus 15. I can subtract 15 from both sides. I get negative 15 equals 5x. Divide both sides by 5. And I get negative 3 equals x. So my x-intercept is either negative 3 or negative 3, 0. Okay? And depending on whether sometimes you're asked specifically for the coordinates of it. If you're asked for the coordinates, you need to give this one. Otherwise, generally, you can use either. Okay, when we're looking for the y-intercept, that means that we need x equal to 0. So I've got 3y equals 5x plus 15. 3y equals 5 times 0 plus 15. So 3y equals 15. Divide that by 3, divide that by 3, and I get y equals 5. So my y-intercept happens at 5 or 0, 5. Okay, those are the two options. Okay, I didn't bother doing this second part. This is just I don't remember why. Oh, because it's got squares in it. So we're just not going to worry about this. This is actually beyond the scope of this course. So let's go into this, because this is where we're going to be using it. And this example is going to take a bit of work to do. Okay, Lisa purchases a new car for $20,000. The value of the car can be represented by this formula. Always pay attention, because it will tell you what the variables are. So V is the value of the car in dollars, and T is the age of the car in years. So we're going to complete this table using this formula. Okay, so when our input value, so the value of the car depends on how long you've owned it for, how old the car is. So if the input for T is 0, so V equals 20,000 minus 1250 times 0, then my output is 20,000. They give you such a ridiculously small space to put this in here, 20,000. And the ordered pair is going to be 0, 20,000 with brackets around it, because an ordered pair always has brackets around it. And then if it's after 2 years, we have 20,000 minus 1250 times 2. So I get that on my calculator, and I get 17,500. So my ordered pair is 17,500. Brackets around it. 20,000 minus 1250 times 4, and that gets me 15,000. So I get 4 and 15,000. I hope you are doing this on your own, I hope. And then 20,000 minus 1250 times 6 gets me 12,500. So 6 and 12,500. Okay. And then I'm going to plot these. So when time is 0, I get a point at 20,000. And I'm just going to check what's the scale on my graph. So 1, 2, 3, 4, 5. So each grid line is 1 year. because I can't see the whole thing on my screen at the same time. So at 2 years, it's 17,500. So there. And then at 4 years, it's 15,000. So 1, 2, 3, 4. And then it's 6 is 1250. So 1, 2, 3, 4, 5, 6. Okay. Now, and it says to connect the points with a straight line and extend the line. So remember, when we want to do a really accurate line, we look at what the what's happening between each of these points. So for each of these, I'm going down 1, 2, 3, 4, 5, and over 2. 1, 2, 3, 4, 5, and over 2. So I'm going to start here. If I go down 1, 2, 3, 4, 5, and over 2, I'll have a point there. 1, 2, 3, 4, 5, and over 2. 1, 2, 3, 4, 5, and over 2. 1, 2, 3, 4, 5, over 2. 1, 2, 3, 4, 5, and over 2. Okay, so just when we talked about interpolation and extrapolation, which I don't know, you did that last year, I think, should have done it last year. Just remember that some of these points are actually extrapolated, and I'm just putting them there so that I can get a better line. That was the point of doing that. So I'm going to go up here, I'm going to put one end of my line here, I'm going to drag the other end of my line down to this point, and this is just going to get me a better, more accurate line than if I had tried to just line it up through those three and then extended it. Okay, so actually I'm going to go back and I'm going to just put bigger dots at my actual data points. Okay, there, those are my actual data points. Okay, so what does the ordered pair 0, 2,000, or 20,000 represent? So that's the price at time 0, right? That was the purchase price. So this is the purchase price. We know that from the question, purchase price. And that equals price at time 0. Okay, and being able to equate those two is really important. Use the graph to estimate the t-intercept. So the t-intercept happens when the graph intersects the t-axis, which is here, and that is 16 years. And what does that represent? That's when the value equals 0. Okay, so 16 years is time for value to be 0. Sorry, to be 0. I did not plan that very well. Use the graph to estimate the value of the car after 3 years. So let's find 3 years on the graph. And it's right here. And then I'm going to go. You sort of fudge this a little bit when you're doing this, because if I just take a ruler and I try and do a line from here up to here, it's not going to be very accurate. What I want to do is visually follow my line up. So I'm following up the 3 years, 3 years, it's up here. And looking at this, I can see that it's actually halfway in this spot. So I'm going to put my dot there, and I'm going to draw my line across. Now, you are expected to do this with a ruler. I can't do it with the ruler on here, and it takes a long time for me to do it with the arrows and stuff. So please forgive me. I'm trying to get this done so I can post it. Anyway, I can see that this one here is halfway between these two. So it's going to end up halfway over here. So if this is 16,000 and that's 17,000, this line here would be 16,500, and halfway through that would be 16,000. So at 3 years, it's 16,250. Okay, and at 10 years, that is, maybe I'll do this with the line. If I look at, okay, if I start at 10 years and I come up here, it's actually right at this intersection right there. Okay, so my other line is going to be, my horizontal line is going to go right from that intersection straight across, and it's going to be 7,500. Oh, see, that's hard to do with this. Sometimes it doesn't even let me. It snaps to some invisible grid thing. Okay, 7,500. So at 10 years, It's 7,500. Nope, that's too many zeros. Okay, and at 14 years, draw a different color this time. Draw line. 14 years is going to be here. And looking at my graph, I can see that it's right at the dot again, so it's right there. And then do another line, draw line here, and it's going to go right across to 2,500. Okay. There. So 14 years is $2,500. This should all have dollar signs here because it's a value of the car. Okay, all right, use the formula to verify D. So D2, which is the 10 years. So the formula was V equals 20,000 minus 1250 T. And so if I replace this with T equals 10, this becomes value is 20,000 minus 1250 times 10. And I get my calculator and I get 7,500. So that matched what I got on the graph. Okay. It won't always be that nice because it won't always be right at a lattice point. Graphing is never as accurate as using the formula, but sometimes graphing is important. Use the graph to estimate when the car will be worth $5,000. So this time, this is I'm looking for $5,000 on the graph. So I'm going to find the 5,000. I'm going to go across here, and it's just a little bit past. So I'm going to just kind of eyeball. I want to land the same distance past. So that's like what this is. 10,000, 11,000, 12,000. That's 13,000. So what, 12,100? Oh, this is years, sorry. So it's just a little bit more than 12 years. Let's just go with that. 12 years, that's close enough for this. And half the purchase price. Well, since the purchase price was $20,000, we're looking for half of that, or $10,000. So we're going to figure that out first, and then we're going to find our $10,000 on the graph. And it's going to be there, and it's going to come down here, and that is at about 8 years. Does that make sense? Yeah, if it declines at a constant rate for 16 years, it makes sense that it's going to be worth half its value halfway through, right? And then use the formula to verify F. So we've got the value equals 20,000 minus 1250 T, and we've got the value is 10,000 equals 20,000 minus 1250 T. And then I subtract 20,000 from both sides. I get minus 10,000 equals minus 1250T. This is just your basic one-step algebra question. Divide that by 1250 or negative 1250. Divide that by negative 1250. And I get T equals 8. Yay. So that's what matched that. That's a terrible smiley face. Okay, that matched my thing. Okay, the original value of the car is $20,000. It depreciates in value by, now I'm not sure how you're supposed to know that. I know that it's 1,250 because, I guess I'll teach you this. It tells me that it depreciates by 1,250 times the number of years. So after 1 year, it's depreciated by 1,250. 2 years, it's twice that. After 3 years, it's 3 times that. We'll do a lot more examples, but that's where you get that from. And it has no value after 16 years. All right. The next page, what does this say? In this lesson, using algebra determines the exact values for intercepts, and the graph gives an estimate. We already talked about that. And here's the interpolation and extrapolation. So when we use values within the data that we were given, that's why I graphed this. So this value up here, this is interpolation because it's within the data we were actually given. And it's just a little bit not really accurate because we weren't actually given this data. We calculated from the formula. Don't like their example here. Anyway, these ones were extrapolated. They were beyond the data we actually graphed. So extra, external, exterior, exit, outside of what we were given. So that's what extrapolation is. Okay, there you go. Have fun with this. I'm just looking through this. Yeah, go ahead, do the practice, and I'll see you in the next video. Bye.